We are 4, 3, 2, 1. Let's go. What's up, everybody? Welcome to the Artists of Data Science Happy Hour. Very special happy hour indeed. It is the 2-year anniversary of the podcast. 2 years ago, on April 8th, 2020, we released the first batch of episodes. I think it was like 12 episodes all at once. And Synthesis, I think, was one of the first in that cohort of episodes. Damn, I feel like so long ago, man. And here we are 2 years later. What are the stats? What have we done in 2 years? Well, about 158,000 downloads. That's, not too bad, just coming in on streams. This month was actually the biggest download month. I don't know what was happening, but I had 25,000 downloads in 1 month, just this month. Last month was like 12,000. The month before that was 7,000. So it's like, this is going up, man. Thank you all for tuning in. 237 published episodes, 268 hours of published content, and 76 happy hour sessions. Goddamn, man, that's crazy. Thank you all so much for being here. 2 years, man. Didn't even know if I would last 2 months. Didn't know if I'd lose motivation, but all y'all have been here. Vin, Ken, Tom, Serge, Russell, Auntie Patrice, and everybody listening at home, man. If it wasn't for y'all, I probably would not have gone on for this long. So thank y'all so much for being part of the Artists of Data Science. 2 years, man. 2 years. It's awesome. Hopefully you get a chance to tune into the episode that was released today. It was with it was all about creativity, and it was Natalie Nixon, the episode that we did. She wrote a book called Creativity Leap. That was actually an episode that was live streamed a few months ago. So if you're looking on YouTube for the video, it was a previously live streamed video. So go ahead and check that out. But yeah, it was released today on the podcast. So hopefully I'll get a chance to tune into that. But yeah, thank y'all for being here so much. 2 years, man. 2 years ago. I'm curious, what was life for you like 2 years ago? Let's start with Kenji. 2 years ago, what were you up to? And if you reflect back on those last 2 years, Ken, have you done everything that you wanted to get done?
I don't know if I did everything that I wanted to get done, but I did a whole lot of stuff that I didn't even realize that I wanted to do. And it sort of, worked out. I'm really happy with how the last 2 years have gone. I think around 2 years ago, or like just before 2 years ago, I'd quit a job that I wasn't really liking to pursue a significantly higher risk job and career. And there's a lot of question marks, like there was not as much financial security. I still had a lot of student loan debt, which I guess I still kind of do. But, there were a lot of incredible things that happened. One of them, namely being a part of communities like this, meeting so many people, which inevitably led to friendships, which also inevitably led to opportunities, both professionally and personally. And I couldn't be more grateful. And I think that's one of the major things that we share is our love and value for just community creation in general, and just building something that's bigger than ourselves.
I couldn't agree more, Ken. Thank you so much. Shout out to Patrice Johnson and Stephanie Ireland in the building. You guys haven't seen you be here before, but I'm so happy you're here. Would you guys mind sharing 2 years ago what you've been up to compared to now? Let's go to Auntie and then maybe Patrice or Stephanie if you guys want to jump in. But yeah, tell me what was life like 2 years ago compared to today?
Yeah, everything's changed. I was barely starting the whole journey into data 2 years back. So I don't know.
And you're still on that journey. It's a lifelong journey, man. You never quite reach a destination here. Tom, let's hear from you. Then let's go to Vin. Let's go to Serge. Let's go to Russell. By the way, all y'all joining in, if you got questions, go ahead, drop them in the comment section or here in the chat. I will add you to the queue. More than happy to take your questions.
Sure. So I'm not sure you heard of it, but this little pandemic named COVID hit the world, and it forced me to go online more, which I was already trying to do. And I got shocked by how many people wanted to be mentored by me. And after a while, I just said, okay, I'm going to accept this. And that got me closer to Danny Ma and this super good looking Indian guy that was raised in the States named Harpreets Question, who gives to our community more than anyone I've met. Honestly, Harpreet, I'm not just saying this because it's your second anniversary show. Everybody sees me praising you a lot with the Chris Evans torch image. But seriously, the amount of research you do for each Artists of Data Science episode, how hard you work. I think I work hard. No, just remember Harpreet. He works harder. But then just getting more and more involved on LinkedIn and getting to know amazing people like Serge and Ben and Ken, and I could keep going, making great friends like Russell and Dare and Auntie. It's been quite a ride. In other words, I don't have office friends anymore, except my dogs, which have been my best office mates to date. But now I have friends all over the world and people that call me dad from all over the world. It's been amazing. And I hate that it was COVID that made that happen, but in a way, thank you, COVID.
Tom, thank you so much, man. No, appreciate that. Appreciate the kind words very much so. Yeah, I don't think the happy hour sessions would have like taken off the way they did if it wasn't for like that COVID wave. Like for a while, we had like 50 people showing up every single week. They were getting crazy. And I think a lot of that had to do with pandemic. Absolutely agree with you in terms of making friends from all over, many of which I'll be running into in a couple of weeks at ODSC in Boston, ODSC East. So if you guys are going to be there, definitely look for me at the Pachyderm booth. I'll be giving out stickers and socks and all that stuff. And I'm looking forward to Ken's keynote address and looking forward to Serge's speak. Serge's talk, not speak. I'm looking forward to him speaking. Also, who is it? Keith is going to be there as well. It's going to be great, man. It's going to be a lot of great speakers. So if you're going to be there, look for me. Then what was going on 2 years ago, man? By the way, if you guys got questions, please do let me know. I'll be adding you to the queue.
Yeah, it was COVID. And like my daughter was right back there. That was all of a sudden her desk showed up and she started working right behind me. And I think hated every minute of it. Maybe not every minute, but I'd say like 90% of the minutes. But that's what I remember is just having her back there and her and I just kind of sharing an office for 3 months. And it was, it was kind of awesome for me. And like I said, that's 2 years ago. That's what I remember the most is, for once because I've been working in this office by myself for 10 years now. And having an actual office mate for that long was like the first time I'd had anybody in the office with me for that long continuously in that whole 10 years. I'd go on site for a week at a time. But yeah, it really strange times, but how you've kept this going and, built up a bigger and bigger community and the people that you bring in here, some of the knowledge that you bring, it's kind of amazing. I mean, 2 years. It feels like it's been longer than that because you keep getting these guests. Like when you got Eddie Duke, I was like, how did you do that? You're my idol. You've been doing some amazing work. I gotta hand it to you. It's really impressive.
Thank you, man. I appreciate that. Yeah, I had some crazy guests on the show, man. Annie Duke, Scott Young, Robert Green, James Altucher. I'm sure there's many, many more I'm missing in there. Yeah, a lot. Can't even remember them all. But yeah, dude, 2 years ago, dude, like the direction my career is taken, it's been interesting. 2 years ago, I thought I wanted to be director of data science or chief data scientist or something along that path. That's like very much where my headspace was at. Now I'm like, dude, like I don't want to manage people, like don't want that type of role whatsoever. And now I found myself in a type of role where it's actually like I'm a professional content creator and community person. Like this is my full-time job. Is I write blogs, I talk to people, I create tutorials, I write examples, code examples. I'm on social media. Like, this is an actual job that people pay me a lot of money for. Like that's insane to me. 2 years, man. Who knows how much changes in 2 years? Patrice, let's hear from you, if you don't mind.
I want to say thank you for, I was trying to find it to stick it in the chat here, and I can do that quickly, but you wrote a post earlier this week listing out all the people you learned from on LinkedIn. And I love it when people do things like that, because I'm back like probably before where you were when you wrote that post about how you joined LinkedIn and then found all these people who knew more about things related to data science than you did and found them to follow. And that's exactly my story, except I would say I'm starting at like a few pre-beginner steps before you, but I do love that I've found people who are happy to share what they know and connect with others. And I also want to say thank you to Tom, because you were one of the first people I saw do that. You were interviewed by Sarah. Please help me with her last name. All I remember without looking it up is that it starts with H and it's long. Sarah somebody.
Yeah, she officially goes by Sarah somebody now because nobody can pronounce that name, but I think she's soon to be married. So let's just call her Sarah the Geek.
Okay. Sarah, who interviewed you. And it was I think for people who are starting out, it's very easy to see people who have done a ton as inaccessible. They must not have time. They must not be interested. But watching the interview that you did with her, it was videoed, and then she posted it to LinkedIn. So I saw it at some point after that. That conversation was so real and interesting, and I appreciate it. It was one of the first places where I saw, wow, there's a lot of people who know a lot, who are willing to share what they know and enjoy talking with other people who either do what they do or want to learn how to do what they do. So
Patrice, I want to share a secret with you. Harpreet and Vin and Sturge, they're all going to back me up on this. The secret to knowing more in this field is giving away what you know in this field, because then people want to give back to you what they know in this field. In fact, Dare, George, and I were having a long talk last night, and I had to really work hard, Patrice, to convince him. Now, Dare, in the future, I'm going to need your help. And he was having trouble imagining that he would be able to help me. And Vin, back me up here. It's going to be a matter of at most 2 or 3 years where he's going to know something I don't, and he'll be able to help me with something I haven't covered. Because it's not only growing fast vertically, but it's also broadening all that we do. So unless we focus on concepts, it's super hard to keep up with everything. But just keep giving it away, Patrice. And it makes you understand it better when you give it away too.
I love that. But I have one more question, maybe for everybody, if other people have thoughts on this throughout this session. I am a transplant into anything at all STEM related from English. And I think that I've been wondering things like, is this a STEM field thing? Is this a timing thing? Because the first time I went to school was many, many years ago. I am experiencing for the first time an environment where people are like, don't share what you know. Keep it like, don't talk with others. Don't do study groups. And I'm like, I don't understand this world. Where did it come from? Because it's not the way I think of education at all, but I don't think that that experience is rare. I think there are a lot of institutions where that's become a thing, or maybe it's always been a thing. I wouldn't know because I don't come from math or science, but it's a thing I'm curious about if other people have comments or thoughts.
I think Makiko might be able to speak to that part about coming into the field from like a non-STEM-ish background, and if you want to attack the other half of that question. And if anybody else wants to chime in, please go ahead and just like use the raise hand icon. I'll add you to the queue. And if anybody else has questions that's watching on LinkedIn or on YouTube or here in the room, let me know. I'll go ahead and add you to the queue.
Hey, so I only caught part of it because I was a bad student, like always. But in terms of people sharing information in STEM, and especially data science and machine learning, what I find is that I feel it's more a hallmarker of domains or disciplines where people have a kind of like a huge stake to some degree in hiding behind like an ivory tower. Like what I mean by that is, and once again, like I only caught part of the question, right? So for example, like I found that there are pockets of engineering, like web engineering, web dev, mobile, where I can talk to people and they are really, really happy to share information. And to some degree, I've also noted that those are areas where you don't have like a high degree of pedigreed people. So people who went through a PhD or master's program. And what I found is that a lot of the people who come from like, who kind of had to self-teach, they tend to be a lot more willing to open up and share because they understand like how hard that struggle was. Whereas like, I think data science and machine learning, I think I think now we're seeing a lot of people from non-traditional backgrounds start to really kind of penetrate that area. And so you're going to see that open up more. But I think part of it too is also the fact that if you're a person who feels like your value is based in scarcity, then you don't have an incentive to like share your knowledge and to help out the people around you. Whereas if you're someone who believes you grow more by sharing and exchanging, then you're going to be really happy to help people. Because I've worked with like staff and like principal engineers who felt very unapproachable, and I've worked with other staff and principal engineers or data scientists who are like, yeah, like let me go debug this really stupid bug that you included in your code because you weren't paying attention. And they're just happy to do that. And they're happy to point out links. So I think, there are definitely like pockets of people who are in that scarcity mindset of like, I need to protect my turf and I need to do that by gatekeeping. But I think the cool thing about people here is that no one here is like that. So yeah. I think you can find your tribe, you can find your like group of people. Sometimes, you go to a company and that culture is very much about learning and developing, and they will show you that by the amount of educational opportunities they offer you. Maybe, for example, they have internal classes that you can do. Maybe, they're very happy to do hackathons, right? But sometimes the company culture won't be there, and you can kind of take that as an opportunity to kind of like build that tribe around you. And that's something that like I have personally, that's been my approach. I either find really cool people, I shortcut it by like just hanging out with people Harpreet knows, because whoever Harpreet knows is pretty cool. So I shortcut it that way. Or you can kind of sometimes do the, unfortunately, kind of hard work of like building that culture where you are locally, even in small ways. Like if you see a hackathon, you can just be like, hey, bud, I know you like your Fridays, but how do you feel like spending the weekend with me on a hackathon for Great Expectations or something like that? Yeah. Or even starting a book club or stuff like that, right? So, definitely there's hope for sure.
I actually just found a class where like somebody asked, like, is this going to be a place where like we start talking about plagiarism and we're really careful not to share anything with each other? And the instructor went, no, everything is going to get turned on on Colab, because the point is everybody's here to learn from each other, including me from you. And I'm like, oh, there are like classes in this discipline that work like this. So that was really exciting to see. But thank you for sharing your perspective on that. And also, can I toss one more question into the pool? I would love to hear from anyone who would like to share what a best Python learning opportunity they've had is.
Awesome. Let's go to Costar and then Ken. I think they're touching on the earlier parts of your question. And then if anybody wants to, let's go ahead and in terms of the Python learning opportunity thing, let's go ahead and just answer that question in the chat. So Patrice, keep an eye out for that. And then if nobody else has a question, we'll circle back to that one. Costar, let's hear from you.
Yeah, I mean, I think one of the interesting things I found, I studied engineering and computer science at the same time, right? So one of the strange things that I found was they kind of operate on very different wavelengths, at least at Sydney University, right? Now, the you'd have the same systems, right? Like a class forum of sorts, right? But on the engineering side, no one would touch it. Mechanical engineering subjects, electronics, like robotics, no one would touch it. It was all about, you're in the lab, you're working on something, you look over your shoulder and talk to the guy sitting next to you or the girl sitting next to you and ask them, hey, how'd you get that to work, right? And it was very collaborative and very very verbal. On the other hand, you look at the computer science side, and if I tried to do that in a computer science lesson, they would just not answer me and just tell me, hey, go check the forums, right? So they were very forum based in terms of how they shared knowledge and how they asked for information across each other. So I did find that different like classes and different subjects had different personalities among them, and I'm not sure what the root cause was for that, but basically all the engineering subjects ignored anything to do with forums, and all the computer science subjects ignored anything to do with interpersonal collaboration. We're just all on the forums. And I think that'll vary from school to school, country to country, communication style. So I think you're going to see a fair chunk of variation there. So yeah, that's kind of my 2 cents on it. It was just a weird experience for me transitioning, because I naturally fit in more with the engineering side, because I'll just, voice up and ask a question to anyone who's around me working on the same problems, right? So yeah, I think we're all going to have different comfort zones.
Awesome. Thank you so much. Ken, let's hear from you. Then after Ken, we'll go to Serge. If anybody has a question, go ahead, let me know in the chat, in the comment section. But if nobody has a question, we'll circle back to Patrice's second question.
Yeah, I would argue that most disciplines are moving more towards a collaborative or open nature. I mean, I came before studying computer science, before studying any of these things, from like a business background. And my interest in business was in entrepreneurship, but most universities or places don't teach entrepreneurship classes. And one of the biggest things that I found from the business classes is they're like, oh, you have to create this competitive advantage and you have to protect it, right? And when I started doing my own version of entrepreneurship, when I started going out and like actually like exploring what the world is like when you're starting your own business, it's actually kind of the opposite. You have to like build something, get feedback, see if it works. You have to share it to vet the idea and see if it's good or not. And I look at this whole domain, I look at all of learning as the way that I can validate if what I'm doing is correct is I have to put it out into the world and I have to share it. And to be honest, if I do that, like the odds of me getting funding for that idea go up. The odds of any of these other things go up that are in line with me producing that or making it a reality. The more I hide my ideas or the more I keep them to myself, the less likely they are to happen, because I probably won't have access to the resources. I'm not that smart. I'm pretty sure if I have a good idea, someone else has had it. And the battle is really getting to execution. So who does it first rather than who had the idea first? Because I don't think that there are very many super original ideas out there. And that's a long way to say is I personally seek out communities. I personally probably overshare about a lot of the things that I'm working on, because honestly, if someone takes what I did and they do it better than I did, then something that I wanted to be in the world is already in the world and I didn't have to do any work on it, right? So there's this kind of unlimited well of good ideas and things that are out there, and just reinforcing that and sharing it, I would hope makes the world a better place, as long as the things you're working on or the ideas you're sharing are like mutually beneficial for a lot of people.
Serge, let's hear from you.
Yeah, I agree 1,000% with what Ken just said. Well, I found like in academics, it's like really skewed. Yeah, it gets really competitive. It operates more like under what Mikiko said, more like scarcity. There's only so many people that can get A's and only so many that can get B's and so on. So of course everybody's competing, and because of that, like people have a tendency to collaborate less. But out in the field is very much different. I think yeah, there is some people with that academic mindset, and I found such folks in my company, people that work in R&D that come from a very strong science background. Some of them still have that, like they're trying to control the knowledge that they have. But at least like in the data science area, I found that not to be true. We have my own team. We have like a fun and learn session that we do every couple of weeks, and we share like what we've been doing, things that, that practices that we like to share. And like every month, like the greater team, hundreds of data scientists spread across many teams in the company. We have the community of practice meeting where we call it the COP, where we share like also things that we're developing across several teams. So it's been a wonderful way to cross-pollinate and realize what techniques we could use and how they tie in into like the agronomy that with the domain knowledge that we're trying to connect with those methods to begin with. So yeah, I think it's you'll find that if you work in a company and they don't have that kind of structure, that they're all trying to be gatekeepers, that's not a good company to be in, and you should probably just run.
How do you identify those? I mean, I 1,000% agree with that, but I do you have any thoughts on how you tell, like, unless you know someone already who can give you an inside perspective or have a way to find someone who has good knowledge of what it's like to actually work there? Are there other indicators, I guess, other things we could look for to that are signs of it, if a company is one that welcomes questions or and sharing and that, or is the opposite?
Well, you pretty much you have to find a buddy or several that work in other departments rather than your own to get a perspective. Find those people, ask them questions of how it is working in that company. And then, you have to be very particular into finding if the work is very siloed. If, you ask if they know other people from other departments, if they know what they're doing, what they're up to, and if there are opportunities to share that information. And by the way they answer that, you might find out if they have a culture of sharing knowledge. Like the company I was in before this one, they were very, very siloed. And it wasn't that they were purposely siloing themselves, it just was the structure that was there. The way the departments were set up, the way they were meant to be working on only one thing. And also there was a competitive streak amongst all the people in there. And I guess that's just the kind of professionals they chose to hire. But I mean, that cultural stuff is stuff that it's really hard to get to early on unless you kind of ask the right questions to the right people. So just make sure you spread things out, because you might get a different perspective if you ask people in completely on the other end of, maybe it doesn't even have to be data scientists. You ask people that are engineers or marketers, and you'll get a different perspective.
Yeah, thank you. I think that's definitely a key I'm after, is finding the people who believe that being competitive and being the best has everything to do with the way you said, a culture of sharing knowledge. Because the more you share, the more you know, back to Tom's earlier comment. So thank you.
Serge, thank you so much. Serge, you're speaking at ODSC. What's your topic?
Adversarial robustness.
Adversarial robustness. I'm definitely going to be at that talk. I'm looking forward to it. And looking forward to meeting you in person as well, man.
Same here. Same here.
Getting a couple of beers over there at Trillium. By the way, if you are listening and you are going to be at ODSC on April 19th, which is that Tuesday, 4:30 p.m. Eastern time, so there'll be a bunch of people coming together from the MLOps community, from the other MLOps community, Chip Twins community, and just people on LinkedIn that I invited to get some beers. Do come and join us. It's gonna be a good time. Ben, let's hear from you on this topic. ODSC, not Europe, ODSC East in Boston. Ben, go for it.
And the topic was the one from, is it Patricia, on finding cultures that work with, maybe rephrase the topic so I can make sure I hit it.
Yeah, Yeah, Patrice, can you?
How do you, what are some things to pay attention to or consider to help figure out if a company is a place that values, I think the best way is not the way I said it, but actually the way that Serge just said it, that values a culture of sharing and knowledge. And I would add to that, like sees that as compatible with being highly competitive and doing great work, not as an opposite to that.
Yeah, I think that's a great question. I think I agree with a lot of the things that have been said already. I think something you could ask them would be, how do you process bottom-up innovation versus top-down? Because something that happens when you get people in an industry, they've been very successful for a reason. They get into these silos and they can have an attitude of not listening. And so if they can't explain to you how they accept bottom-up innovation, if someone has a good idea, then that might be a red flag if they don't have a process to incorporate that. Because I think what I've learned in industry is everyone can have a brilliant idea. The brand new junior person joining the team could have an absolutely brilliant idea that changes a feature, changes innovation. And if you don't have a process to accept that is very welcoming, then that would be a big red flag.
Thank you so much for saying that. You totally just made something click for me.
Oh, good.
So like several years ago, before I had any thoughts of doing data science, I won an essay contest from the Japanese Business Society of Detroit to spend 12 days with red carpet treatment in Japan, because Japan had this initiative to help teachers outside of Japan understand some very particular things about Japanese culture that would help their children of employees who go to work overseas adjust better and get more out of that experience. And one of the things they did is in the city of Toyota, like Toyota the company, there's also a city Toyota, and we met Mrs. Toyota, and they gave us a tour of their factory floor, which has been written about in many books. I know Eric Ries's The Lean Startup, that was the first place I heard it, but I think that's now quite a famous story. But what surprised me was they did this long kind of stop and story to explain that they have a way to stop production when workers on the floor have anything that goes wrong, and then a whole bunch of people come to problem solve it, and there's not like more things piling up. That's the lean part. But then they also did this like deep dive into a story about one worker who gave them the idea, like that came out of a worker whose responsibility was to put things inside of the cars. They used, because when you tour their factory floor, one of the first questions that comes to mind is, why are there no doors on the cars? Because they seem all assembled except there are no doors on them. That's because the people who have to put things inside of cars used to have to open the doors, then very carefully walk around them slowly to make sure that they weren't scraping, like nothing they were carrying or wearing would scrape the paint on the exterior of the doors as they were going to the interior to install or assemble or fix things. So it was taking a lot of time and slowing them down. It was, and there really was no reason the doors had to be on the cars when they didn't have all of their pieces yet. So they have, and throughout Japan, like everywhere we went, every experience you have, you're surveyed about it. And I think that's exactly what you were talking about with, like, that would be one method to gather bottom-up ideas, is to ask. Because often people will tell you if you ask, and if you don't ask, it makes it seem like you don't care, and you might not actually care, or it might just not occur to you to ask. But I'm like, what? At the time, I was like, why is this a big deal that somebody suggested the doors were in the way? But now in a different context, and when I'm asking different questions, I'm thinking, oh, like that's actually a very good example of the values of that company and how they live their values day to day, and how there are structures built to support those values, which is a very different story than, I mean, any company can have a great tagline and a great list of values, but the extent to which they really internalize them and make it a positive and instructional and competitive and learning part of what they do is I think what at least I think a lot of people really want to know about a place. It's not just companies.
I love that example you give, because in the negative work culture settings, the people doing the installs that required to open the doors would not have been invited to the meeting because they're not senior enough, they're not important enough, and their opinions aren't useful enough. And so I think that is the negative side that we see.
Absolutely.
So thanks for sharing that example. That's a beautiful example of why we need this.
Thank you very much, Patrice. Costar, let's hear from you.
Yeah, so very interesting experience I had. So when I was at City University, I was part of the Formula student motorsport team, right? So we'd all build cars. Different universities would get together and we'd do time trials and endurance runs and things like that, right? It was a massive engineering exercise. Loads of fun, right? One of the best learning experiences I ever had, because I got to work with people across multiple years at university, as well as with different professors who would advise us. But we had, I think it was one of the German teams. Whoa, sorry about that. I think we had one of the German teams come across. This was probably back in 2015 or 14. And when we had something go wrong with the car, we pretty much had it separated down to like departments. So if there was something wrong with the electronics or the wiring loom or something like that, it would be down to the electronics team who'd come across and have a look at it. Now, in their team, what we found was until the car was ready and perfect, if there was something wrong with the car, even if it was just something wrong with the engine tuning, the whole team would essentially be present around the car and taking ownership of the entire problem. Even if you didn't have anything to offer in that moment, just watching the guys who were experts on the engine work on the engine could give them insights into other parts of how the car operated. So it was very interesting to see this whole thing where you literally had 20 people standing around a car watching two guys try to fix this thing. And occasionally one of them would pipe up with a different idea. Like in terms of how you can potentially program the ECU a little bit differently. And they'd be offering up ideas. So it was just interesting to see that more hive mind kind of thinking. And it's to me at like a corporate level or like in a workplace, it's about how efficient that is and how often you use that. Knowing when and how to use that to maximum effect is quite powerful. But I think, there are certain situations where that kind of hive thinking or mob programming situations can be very useful. Just yesterday, I found me and a couple of my colleagues, we were training plenty of models over and over again for different use cases. And basically we were running into similar issues, but just having like an open chat line, like a huddle on Slack where we could just talk verbally. We managed to catch each other out on errors before we ran into them because someone else had run into it. So that kind of collaborative thinking kind of seeps across if you're able to execute it intentfully enough.
Thank you so much. All right. See if there's any questions in the queue. Russell has a question. After 2 years, wants to know my favorite moment episode the last 2 years. Definitely two favorite episodes I would say is Robert Greene for sure and James Armstrong. Just those are like two people that are just huge in my thinking and huge in take up a lot of real estate on my library bookshelf as well. So it was wild to be able to talk to them. And then also just the happy hours. That's definitely one of my absolute favorite times as well. Let's go to Patrice. You had another question about learning Python. Let's circle back to that. By the way, if anybody else has questions on YouTube or on LinkedIn, let me know. I'll go ahead and add that question to the queue. Or Mark, the question or a comment?
I was a comment about Python, so I'll wait for the question.
Okay, all right, cool. So right after Patrice goes, then we'll go to Mark.
Oh, the question was just if you have any favorite Python learning opportunities.
Yeah, so my favorite, so self-paced, I will forever plug dataquest.io. Honestly, that's how I learned Python for myself. Learned on the train, going to my job in operations, and picked up Python that way. Makiko said real Python. I reference them all the time, especially their classes tutorial. But the main thing that really, from me going from I know how to use Python syntax to I actually know how to code in Python, was actually working in an Eng code base and getting code review. And more importantly, is that in an Eng code base, so typically have this thing called CI/CD, continuous integration, continuous deployment. And it's probably gonna be hard to get that for your own personal project, and maybe open source projects that have that. But essentially, engineering code base, Eng. And essentially, is with those tests, they're gonna have a whole bunch of unit tests and linting and all these different features that's gonna force you to write good code. And so a really great example of this, I built one of my first ETL pipelines in production recently, and an engineer put a new test in, and my code kept on failing on this new test. It forced me to understand their code, and then it forced me to write even better code to account for some errors. And so that's something that I just couldn't get on my own, because it took engineers or people who are more advanced to write these tests, and for me to force me to consider them. And then after that, so say for instance, maybe you can't work in a production code base just yet, you're still learning. Going on GitHub, putting your code up as if it was a real branch, and then asking someone to do code review. I've learned so much from code review. I think that's where I really learned how to really do software development. I wouldn't call myself a software developer quite yet, but getting those best practices from someone who actually knew what they're doing, just really brought me to the next level. And so identifying people, and what I've done for friends is one of my friends learned how to be a front-end engineer. I just reached out to my network. I said, hey, my friend has a branch up. I'll give you some data advising if you go and do code review for my friend. And people were happy to do that. So I would greatly, greatly encourage getting code review to really bring your Python to the next level.
Thank you. I will message you as soon as I'm ready for my first GitHub code review.
Yeah,
I will happily do it.
In terms of just learning language, just say from the actual ground up, from scratch. My favorite resource is from Python Principles. I think it's called pythonprinciples.com or pythonprinciples.org. Probably one of the best ways to learn Python. You don't have to install it or anything. Everything's done on the web browser, and you learn syntax from literally what is a string, what is a variable type of thing. I actually put my cousin on it, and he is in 10th grade, and he went through the entire course and said he absolutely loves it. And I also put another one of my cousins on there, for electrical engineering, and it's at the end of his bachelor's, and he's really enjoying that as well. So definitely check that out. Ken, let's hear from you. And if anybody else wants to jump in on this, let me know. And if anybody else has a question, let me know. I will add you to the queue.
Yeah, I'm going to go a different angle with Python. So rather than the general learning, at a high level, I think that there's some cool opportunities right now that are going on to learn specific tools. So my friends over at Streamlet are doing a 30 days of Streamlet challenge, where every day they have some really, really in-depth tutorial style things that are consistent with how to build a dashboard using that platform. I think looking for what companies are doing or what open source libraries are doing with their own documentation is really interesting. Most people are oh, I'm not going to go to python.org or whatever it is, I think it's python.org to go and learn the language. But even on that platform, there's a really good tutorial for all of the basics, like loops, variables, functions, classes, whatever it might be. I think it's really overlooked. The people that actually produce these languages or libraries, they kind of have some pretty good stuff out there. So that's something that I know whenever I need to brush up, it's like the first place I look to, and it surprises me a lot. So also shamelessly, if you're looking for some a good data or libraries to work through, I did release all of my YouTube data a couple months ago, and there's some really good examples that people have put together analyzing that with some pretty cool visualizations and some other different types of analysis. So shameless self plug.
Shout out to Kenji's podcast, YouTube channel and podcast, by the way. Yeah, Kenji's got some great resources on learning data science as well, so definitely check that out. And in terms of like learning how to write code that passes tests, I guess there's a course from Ted Petro. His platform, I think, is called Dunder Data, and he had this like essentially like a course that costs like $15, and it teaches you how to pretty much build pandas from scratch, and it teaches you how to test every little bit of your code. So you not only learn how to build an entire data analysis library, but you also learn PyTest as well, and it's really cool. Well worth the $15 that he's charging it. I mean, I would charge more than that. But shout out Ted Petro. Should respond to my message. Try to get on the podcast. Akiko, let's hear from you.
Yeah, I would say one thing I would say is that like the types of resources that are useful at different points in one's development. So there is such a thing where like, I think, and this is something that like, I think I sort of made the mistake when I was first starting out. Like I tried to learn really advanced stuff before I had the basics down, you know? So I feel like, I think in general, it's never going to hurt to build your own projects. And sometimes the building a project could mean taking existing code, like in an existing project, doing like a code along where maybe, for example, you see someone's project. And actually, like sometimes the websites for like Streamlet or, you know, some of these other really popular tools, they'll have specifically a gallery section of projects. What can be really sort of nice is going to that gallery section, going to the GitHub project that's listed, and like trying to take that one project, deconstruct it, and then essentially do like a different version of it. So they might be doing like a forecasting off of, oh, I don't know. I was gonna say rain patterns, but they could be doing a forecasting of like stock or something like that, right? But then maybe you read through it, you understand like, you know, how they're structuring a class object, how they're doing like the training and prediction pipeline. And then maybe you instead do something kind of like a similar setup, but a different sort of forecasting problem or something like that. But I think like, it really kind of depends on where you are in your sort of learning cycle. Like when you're first learning how to code Python, I feel like if you then start throwing in DevOps and you then start throwing in data engineering stuff, it gets really complicated super fast. So I would always check in with yourself on kind of like where you are in your process. And that's a little bit hard. So it helps to talk to other people, more like senior engineers and all that. And to check in to see like what is sort of the bottleneck you need to work on to then progress to the next level. Because I had this huge issue where I was just boiling the ocean on resources. Like I was chasing like every single blog post, LinkedIn article, YouTube video, whatever. And it wasn't helping me be disciplined in the skills kind of I needed to learn. Because essentially once you have good basics of Python, learning pandas, learning NumPy or something like that, it's relatively like easier than learning Python. Once you learn NumPy and NumPy and some of the other libraries, then it gets a little bit easier to understand like how TensorFlow is built, things like that. Or even once you know how to write a script, then it becomes the next step of being able to write classes. And then it becomes the next step of being able to write a package. So I would always kind of think minimum viable piece of learning that you kind of need to do to like unblock yourself, and then try to develop on top of that. So I feel like when I was first starting out, I burned a lot of cycles learning stuff that was not supremely useful in the short term. And I'd argue it wasn't useful in the medium term either. It became useful long term. Like no knowledge is like wasted in the long term. But you know, if you're trying to get a job or get a raise, some knowledge is not as useful at some points. So
yes,
yeah.
Thank you. Thank you for thinking also of efficiency there, because there is a lot if you just Google how to learn Python. So I really appreciate all these ideas that are coming from people who have tried a lot of things and used them and shared what they found most valuable. So thank you so much.
Yeah, I'm regularly getting my butt kicked by like all the senior staff, principal engineers around me. It's amazing how little I know and how much they're able to find in code reviews.
Awesome. Thank you very much. Also, shout out to everybody else in the room. Shana, always good to see you. Amber, what's going on? David Kessler, Derek, George, Denise, Perio, Marion, and Naresh. What's going on, man? Happy to have all you guys here. And Krishanu has a question, so go ahead and go for it. Looks like a technical question. Haven't had one of those in a while. Go for it, Krishanu. Go ahead and unmute yourself.
Yeah, hi. Thank you, Harpreet. So I have this data set, and the purpose of me solving this problem was not to actually have a deployable model. We just wanted to extract maximum information from this data set. So that was the purpose. So I went in and I used CatBoost for because it offers a very good model explainability. The SHAP values that CatBoost offers is really cool, and you can explain how each feature kind of plays and impacts either positively or negatively the response variable. But so I was just curious that if there are more models out there that I can use that offer the same degree of model explainability, so that I can at least verify the results that I obtain from the CatBoost model, because I don't using just one model and trusting it, it kind of feels weird. If I get the same results from another model, kind of proves that there is really something, so that is one part of my question. The second is, I have, since my work is mostly in my office is on linear data, which is like numerical and categorical. I don't, but in the market, I see there is a lot of NLP requirements. So I would request you to anyone here to like suggest me a good project, a good idea, so that I can get started with. Thank you.
So I just wish there was somebody in the room here who wrote a book on explainable AI, and also I wish there's someone here that's writing a book on language models. That would be so helpful right about now. Right, Serge? Let's go
Actually,
let's go to,
I read the book. I'm currently in the middle of it.
That's not mine though.
No, it's not.
Dennis is not here, is he?
No, he's not.
No.
So let's do this. So Serge actually also wrote a book on explainable AI. Then after that, Omar, if you have anything to add from your learnings of that book, I'd love to hear from you as well. And then Krishan, then we'll circle back to that second question about NLP. But Serge, go for it.
Yeah, you can definitely, the way to go is to try different models, not just CatBoost. I realize why you chose CatBoost, but it can be any other ensembled decision tree as well. I try even, it might sound ridiculous, but you can try also logistic regression or linear regression. You can gain some insights from those as well. You can throw SVM on it, LDA. It really depends on what kind of problem it is, what kind of models you would throw at it. You can use SHAP on any model. You can try the method that the CatBoost already has integrated uses what's called a tree explainer. It's very quick, but it cuts a few corners. So if you want the highest fidelity, you can try the kernel explainer, one of the other explainers, which is the truly model agnostic one. It's a lot slower, but it'll give you greater fidelity if that's what you're looking for. And it does help to compare the different models. Another thing that does help, but it might be, not as computationally plausible in your case if you have hundreds of features, is try interaction SHAP, which is a good way to see how the different features are interacting with each other. So generally, it's a good idea to do some feature selection, unless you think there's some value in a lot of the features there. If it's a question of exploring the data, what's really the point of exploring all the data if 90% of the features are worthless? As far as like the predictive capabilities that they bring. So I'd look into that. But it is a good way of kind of getting an understanding, trying cat boost and as you did, but then I'd probably try feature selection, I try different models, and I definitely try a different explainer. Even if you're not using, you don't have to necessarily use SHAP, you could use some of the other methods as well. You can get some understanding from them.
Just to recap, you spoke about kernel explainer and tree explainer and interaction SHAP. So are these functions all available online? I can just look them up in the internet.
Yeah. A lot of folks don't know that SHAP, you generally by default, it'll just give you the SHAP values. But you can also, from the tree models and only from any tree model, you can do interaction values as well, which is very useful.
So
because sometimes, yeah, I'm sorry, I interrupted.
No. I was actually wanting to know what interaction SHAP is. Thank you.
Oh, the SHAP interaction values will show you a degree of interactions between the features. So much like a correlation plot would do if you're doing like a Spearman or Pearson's correlation, like you'll get an understanding of how they're interacting. So it's purely associational, but it does have a higher degree of fidelity because it's derived from the model. It's not necessarily from the data, and therefore it's not necessarily a linear or monotonic value. It's something that will tell you to what degree they're tying into the target variable. So that's very useful because sometimes you think a feature is important, but it's only important because it's interacting with another one. So it gets you understanding, okay, this is how they're interacting. And generally you use something like a partial dependence plot to understand that. And SHAP has partial dependence plots as well, which are very useful.
And Serge, question for running like feature selection methods. With so many different methods out there, how do you approach deciding which method to use first? Do you have like a go-to method, or does it depend?
It depends. Sometimes if you have a ton of useless values, useless features, some of the classics, like you can use something like lasso and you'll just weed them all out, right? But that might be a very simplistic way of looking at it. There is a progression that I do. I try all those simpler ones first and see what I find, but I also try to validate them with the more complicated ones. And then I use the set operations within Python to see how they overlap. So like I'll try lasso, or also within scikit-learn you have special variations of lasso that use the BIC values as well of the models, so you can check if they're if there's some value between different kinds of models that it's determining with this feature selection. Forget the name of the feature. It's in my book, the feature selection method that I'm discussing that uses lasso. But more importantly, it's just what it's simply doing. It's iterating through all the different features and using very quickly lasso to discriminate. So,
sorry, did you mention special variation of lasso?
Yeah.
What is that?
Yeah, you kind of put me on the spot here. Select model. There is within scikit-learn, which is a very, very, very complete library. Yeah, it is called select from model. You go to scikit-learn.feature selection, feature underscore selection, and you find a ton of different features. So it has select k best, select from model. So the one I'm discussing is select from model, and the model you use is lasso, but you can also use a variant of lasso, which is lasso Lars ick. Yeah, that's the one.
Sorry,
so that one,
lasso large or Lars?
lasso Lars ick. So it's so it's a lasso model with Lars, which is another variant, using BIC or AIC, which are very good for that particular case, where they're pretty much checking the goodness of fit using these criterions. It's a long-winded explanation, but these BIC and AIC are very, very famous criterions.
Yes.
Thank you, Serge. It was very insightful talking to you. Thank you so much.
Yeah, and well, I haven't finished though. That's the simpler one.
Please go on. Please go on.
I go all the way from that, all the way from using perhaps if you want to be very thorough, there's a bunch of other methods that iterate across every single thing, every single variant of features, kind of trying to discriminate on. They first go, okay, maybe you have 400 features, and in every iteration, they're like trying to take away the 5% that is kind of on the bottom in terms of importance in your model. So it uses the feature importance of the model, and every time it's just like 5% less, 5% less, 5% less, until it's within a threshold of performing well, but not necessarily quite as well as it would with a lot of other features. But sometimes it's not worth it if it's only increasing performance a tiny bit. And then there are newer methods, like one of my favorites is genetic feature selection. I suggest you look into that one too. It's pretty time consuming. It's very resource intensive, but it performs very well. So you'll find, I think it's the name of the library is genetic algorithm. I forget. Genetic algorithm. I think it is called genetic algorithm. Yeah, it comes with a lot of. I don't want to oversimplify it though, and I feel I've been speaking for very long.
All good, man. No, appreciate it. Amar, you said you're been into explainable AI recently. Any input here?
Hello everyone. So no, actually I'm learning about it. I'm still like in my early ages of it. I like it because it's the maturity of this domain. This what makes our domain. This what will make our domain like mature and confident. This will increase the confidence in our domain. For example, I was working with a company here, and they are a client of my company. So they do machines for X-ray. They called Ezaute. It's like a world-leading X-ray company. So they have these X-ray for like a pregnant woman to see the baby. It's called like echoes or something. So they had a problem. We solved the problem using like autoencoder and something. But they wanted, before like accepting the outcome from our side, a full explainable like report. Like, why does it perform how it is performing? and it is like it's independent from the human side because it is all machine related. It's not affecting the humans at all in a sense. So the goal is to make sure that this like the sound that is like the doctor holds in his hand is actually working well without having the help of a technician. So we tried, like we applied something and it worked, but they wanted a full report on explainability. They asked us like clearly that they want a non-professional to understand how this is working. And you know, it's a really hard task, and I've been working on it like for the past month after solving the problem, you know, so it's a big thing for me. So I'm reading the book, I'm taking some inspiration. I'm not reading like every word, I'm not applying the codes, I'm just taking like inspiration on how to do that. I actually have a question in another project where we are like currently blocked, if it's okay.
Yeah, go for it.
Okay, so imagine you have motors, like any type of like small motors that are being manufactured, and when you want to test them, they are like these experts who listens to the like performance of the model. So they just turn it on, listen to it, and if it's okay, it passes. If it's not, it goes into further inspection. So they had a problem. They wanted to automate that. So we took like recordings of the motors, like many good ones, and like a few like anomal ones, me say. And so we have like 40,000 recordings of 5 seconds of good working motors, and like 15 or like to those that have anomalies. So we try to do the following thing, maybe to build an autoencoder that takes the input, which is the MEL spectrogram, which is the visual representation of the audio file, and tear it down into a latent vector in the middle of the autoencoder and then build it back up. So it will learn only the good aspect of a working model. So whenever a working motor, so whenever a new anomal like a recording comes in, it should not be able to build it again because it only knows how to build good ones. So the thing is, we do similarity between the input and the output. And if the similarity is high, if they look like very much the same, it would be a good one. If it's not, then this would be a anomal one. So we are blocked. It's simply not working. We tried many approaches. It's not working. That's it. That's like it's been like 2 weeks since we're trying on this, and it just doesn't work. You know, we have a okay, that's important. We have a restriction over the memory and the deployment because the deployment thing is like edge deployment. They have their own ASIC design of their boards, and they want to integrate it within it. So yeah, that's it. Any insights? Sorry, I spoke too much, but
that sounds like a very tough problem that I've never worked on, so I have no clue where to even start with that. Any deep learning experts here who specialize in this type of problem space?
Not necessarily deep learning. It's just an approach. Maybe other things might work. That would be even better.
Yeah.
Because in our situation, we converted the audio file into an image using MEL spectrogram. This was the main approach. But if there's like maybe other ideas using the audio file directly, that would be great.
Mark, go for it.
Yeah, so I have no expertise for this. I just more so have a clarifying question. Is because what you're sounds very complex. What's like the simplest thing you've tried so far, and then how's that compared to what your current approach is?
So the simplest thing was done by like the R&D team in our company. They tried like RBF. They extracted features out of the because you know RBF is deployable on their edge ASIC design. They have like something called neuromorphic like parts that has like something I don't understand very well, but they have like a hardware that is specific for RBF that works very well for RBF. So they tried to extract features from the audio. Yeah, from the audio file itself. I'm not sure how they did it, and they done RBF over that. It worked to some extent, but it was not a very confident solution.
Mikiko?
I just want to point out that NVIDIA actually has some pretty good like technical blogs and talks on specifically conversational or speech AI pipelines. So it's worth checking it out. Some of it does tend to be a little bit more focused on their platform Riva, but if you kind of sort of skate around it, some of the resources there are pretty good. I posted a link to NVIDIA stuff. And then the other question I had was, I guess I'm not getting a clear understanding of sort of what are the bottlenecks or the problems you're trying to solve for. Is it performance? Is it the structure design?
No, they actually manufacture the motors. They have like this pipeline of manufacturing motors, and for the higher end models, they do like human inspection on every produced motor. And they are trying to automate this human role in here, where a person is usually sitting next to the motors and listening to them. So if they sound fine, they're okay for shipment. If they are not, they are like went back to further inspection.
Yeah. But what I'm saying is that like in the current summary of the project where you're stopped at right now, is the problem that is the problem that you've tried architectures out there in papers and they haven't worked? Or is it like a computational challenge where it's like, you know, the design, the system architecture could work, but you just don't have enough compute power? Or is it you're outputting a pipeline that's doing terribly?
So for the
basically there's like three, you know, for each problem, there's a different solve, right?
Yeah, so actually we have like both of the problems. When we enlarge the model, it works. It is able to learn the exact like good motors, but we're talking about like very large model. And when we like try to make it a bit smaller, when we like do some high parameters, like it just doesn't work, and within the restrictions we have.
Gotcha. I mean, yeah, Costar has his hand up, and since he does all the stuff with like robotics, I would say like, because if it's a computational, don't give that look like you do working robotics. Because if it's a computational thing, a lot of times it's like maybe it could be just throw more money at it to get more like compute or GPUs or what have you. But if it's like not that, then yeah. Costar, do you want to take a stab at it, please?
I mean, well, the two things that pop to mind now, I'm not an audio expert by any wild measure, but just a question. Is there a reason you're specifically using MEL frequencies? Because
there's no reason at all. But like in the state of the art, this is what it seems like to be the best representation of audio, like human listened audio file, how the humans listen to it in image.
Yeah. So I mean, like that might be where part of the bias is, right? Is because when you're talking about MEL frequencies, you're talking about the like non-linearity of human perception being scaled into the frequency range, right? But does a computer see it the same way, right? Like we see. So for example, there's a fundamental difference between how humans perceive objects and how deep learning networks perceive objects, right? We use shapes. Deep learning objects typically use textures, right? So there might be a fundamental perception difference there. So I don't know whether staying away from MEL frequencies might.
I actually like canceled this option because somehow it is visual, the differences. When I put in front of me two examples, one working motor and one that's not working, I can know which one is the one that is good and which one is the one that's bad, you know?
So there are definitely like visual markers in the MEL spectrum. Then.
Yes, but maybe I'm biased because I designed the MEL algorithm. I did the whole thing. I asked one of the company employees to come and look at them. Just give me a burst like idea which one is the bad one, and he figured out which one is the bad one. You know, so.
Yeah, it's really hard to say. Like, I mean, I'm definitely not an audio expert by any measure, but that was just my open question, I guess.
Yeah.
I mean, the other side of it is like when you're testing motors, right? for quality, are you able to take a different approach and use something like a miniature dynamometer or something to run the motor against?
So their restriction is that we don't touch the production pipeline. We don't add anything to it. There's already we had some discussions before even allowing to include recordings, microphones next to the motors that are being tested. So they don't want us to touch anything. We cannot put like an accelerometer over the wheel that is dragging the motor along the pipeline. You know, they don't accept anything, but they want it to be like an outsider solution. With the memory and power, computational power restrictions.
Let's hear from Serge on this, but before we get there, I'm curious, and Ben, if you have any inputs on this, I'd love to hear from you. But does it have to be encoded as either audio or video? Can't you measure, like, I don't know what scale audio comes in, megahertz or whatever, but like you just imagine having like a row vector that samples audio at every given, you know, let's just say 0.005 seconds, and you just pull like some statistic of that audio value. So you have a row vector that each element of that row vector is sampled at 0.005 seconds, and it gets like the maximum hertz or whatever. I don't know, I'm just making it up, and use that as
I think the difference,
I don't know. Yeah.
The difference there, I think, might be that what they're perceiving when they're listening to it is in the spectral domain and not in the time domain.
Yeah.
Right. So trying to pattern match in the time domain doesn't quite line up the same way.
I see. Serge, let's hear from you then. Ben, if you have any input.
It's been a while since I worked with audio data, but something that worked the last time I worked with audio data was there's this library called Librosa, which you probably used before, but I would pre-process the data, pre-process the audio before the MEL spectrogram. There might be something you can do to make the sounds pop more. Okay, you did. The other thing,
there's this like FFT thing, like the fast Fourier transform. It gives you a number of channels, which is somehow correlated to the number of features, you know. So it's called bins. Are you familiar with that? Mm-hmm. So you choose how many bins you want, and those will be your features. I tried to hyperparameter this, like I even automated it. And when you choose a large number of bins, it gets more explainable by the eye, but you get a larger image. So it needs more computational power.
Okay. And you said, speaking about computational power, that you said you needed a very big model and it would work. Okay. Yep. Which to me suggests, okay, it suggests that maybe that's, I mean, to think that that's the only way to solve it, but have you thought of making a big model and then quantizing it?
I tried int8 quantization, like training aware quantization, and maybe again post-training quantization. Both didn't like get very helpful because we are talking about an ASIC design.
Yeah, and then there's another thing I thought of, and it is, I mean, perhaps MEL spectrogram does not capture it because it's designed for human ears, and perhaps there's a lot of sounds that are not going to be represented there, and so maybe you find another way of actually visualizing it. It could still be an image, but I don't know what that would be because I haven't. But I would look for papers that describe that kind of sound and maybe how they dealt with that.
I thought of a backward to double check this, what you're saying. I did an inverse MEL spectrogram. So I reversed the MEL spectrogram into audio and I compared both. It's quite good.
Okay.
You know, and a very high degree. Like, so it is representing well what I'm hearing, but it's not like at the end, like we could just agree that this is a computational power restriction, and that's that, you know.
Yeah, well, Greg probably knows the answer to this, so I'll let him go on.
Oh, I just had a quick question for him, or maybe you said it before, is that when you said you're comparing the big model with the small model, that you could see which one is failing is how are you able to see which one is failing? Are you doing a comparison with, how it's processing the input data, transforming it and making an inference, or how are you able to see the difference between the two exactly?
No, actually, I wasn't very clear. Maybe I compared two Meldor presentations, one for a working model recording, working motor recording, and one for a a normal motor recording. So I compared both images as data inputs, and I was able to see the differences. Where is it failing for the anomal one?
Okay.
Can I ask, what exactly are you, when you look at the the MEL spectrograms side by side, what do you visually see is the marker for, hey, this is a good motor, this is a bad motor? Is it a dominant dominant frequency, or are you seeing harmonic patterns, or what are you seeing that
actually the harmonic patterns are the scary ones, because when a motor stucks, it keeps generating the same level of frequency. So in the MEL representation, I'm gonna see a same color for a long term of time. But when a motor keeps running, when it's still when it is non-functional, you could also not see a harmony, but you would see the I don't know the English term of it. It's the the sinusoidal representation with high peaks. Yeah, the oscillations.
Okay.
And those oscillations in some time are the normal thing when the motor is turning on and off.
Okay. Yeah, this one's definitely a tough one. It's it sounds like a weird crossover on you're kind of reaching the limits on what computationally you can pull out of the spectrum, right? Yeah, which is why this is when I start suggesting, okay, the signal that's driving the motor, do you have access to that signal?
Nope,
right?
Not at all.
Because there could be information there,
like some
back EMF,
feedback. Yeah, exactly.
Back EMF feedback, anything like that might be able to give you something. Yeah, this sounds like we could workshop this.
Yeah, I actually asked them if it's possible to fix an accelerometer below the wheels that drives the motor to the testing place, and they said this is a big no way we would add anything to our existing pipeline.
That to me is always an interesting requirement, right? Where when you're kind of given a challenge to do something with nothing, right? Even if it's something as simple as a couple of lasers and a slip angle sensor kind of thing, that's probably enough to tell you the rate of movement of the motor itself without being contact, without needing any kind of contact. So it's it's always a challenge.
Just so you know, the first discussion was about fixing a camera over the motor. That was their proposition, using the camera, we want to know if it's working or not, So we drove them towards a recording, and that was a tough one. So adding anything else would be a big problem for them.
Could you look at magnetometry? Sorry, I'm geeking out here, but could you look at magnetometry and because naturally, I'm assuming these are electric motors, right?
Yep.
You would see some kind of magnetic field change based on the speed, right?
Yep, makes sense. That's
interesting
idea.
Let's hear from Ben on this, and then after Ben, Greg.
Guys, I'm really sorry I took lots of time for this.
Oh, you're okay. In another life, I used to do a lot of audio long time ago. At IRV, we built out automatic speech recognition systems in-house. So these are deep speech too. We had to train these models for over a month on tens of thousands of hours of audio. And so one of the questions I have for you is, How big is your training set? So how many unique spectrograms do you have? Is it
40,000.
40,000, okay.
Yeah.
And then are you doing 8-bit depth on your spectrogram images, or are you doing the full 16-bit, or when you send it into your model?
I tried both.
Okay. Is there any other data in addition to the audio that you could add to it?
Nothing.
Okay. What time horizon are you using?
Well, like 5 seconds.
And did you experiment with that, doing longer time horizons?
So usually the person who's working there needs 2 seconds to recognize.
Okay. And you said so the human needs 2 seconds to hear it, to recognize. Yeah. What's the human accuracy?
Okay, so we tried this. It's very hard to have a deficient motor comes out. So we faked it. We added some like motors that they know that doesn't work very well. So it was 100% of human level performance over 5 of their employees. Who does this job, you know?
Okay. But you said earlier that you felt like you could tell on the spectrogram.
Yeah. I'm not sure because I'm probably biased, but this is probably the case, yeah.
And when you train your model on the 40,000 images, what model are you using? How long are you training for?
I tried this have like many architectures. The last thing I did, you know, I'm using autoencoders, so a couple of convolutions and then a latent vector. So I take like big convolution, then a smaller to a latent vector, and then I rebuild the image again to obtain a new image. So I compare both images with like some similarity of functions. That's not the problem here. I know that the similarity might be something confusing to compute, but that's not the problem. But I compare the similarity between both, and if the similarity is high, this is okay. This is an normal motor, and if it's not high, then this is a normal one.
Okay. We could take this discussion offline, but one of the things we could do, if you were open to it, is we do audio processing pipelines at DataRobot, where we would take the spectrograms and run them through. The thing that you get is we do the unsupervised clustering for you, and then we do the GradCam visualizations for you. You can obviously do that yourself, but that might be a way for you to troubleshoot. Maybe 40,000 images is a lot for the spectrogram, and maybe there's some quality issues. Maybe there's something else in the data that could come out. So we could talk offline where maybe we run the data. I'm happy to run it through our platform and see if it gets different results, then we can dive into the modeling approach to understand what we did. But hopefully we can get to the bottom of it, because it seems like if you can tell in the spectrogram, that should be a huge giveaway that like this should work very well. There's no reason this shouldn't be working. So yeah. If you don't mind, send me an email, ben@datarobot.com, and we can go deeper.
I just connected with you on LinkedIn, and I do.
Awesome. Okay.
Thank you very much, Ben. Appreciate that. Greg, go for it.
So I have a silly question. Have you tried like different types of models, like a time series? Because when I'm hearing like motor failures, time series is very, especially motor vibration, there are a lot of signals, you know, like the motor vibrates depending on the oscillation over time. You can create time series models that can give you more powerful signals for future failures versus, you know, analyzing images. I don't know if you've tried different approaches to see, you know.
So in the recordings I have, you know, sometimes the human needs to turn on and off the motor like multiple times in order to like to double check to make sure that's working. So like this flow of turning the motor on and turning the motor off should exist in different places of the spectrogram. Okay, this is the first thing. The second thing is that we don't have anything other than the recordings. Okay, that's it. So we are talking about how would we like symbolize our recordings into numbers, into whatever type of data. So when we're talking time series, what type of time series? Is it like just time dependent frequency? It doesn't represent what we hear. You know, so the discussion of is how to represent this audio file in a human interpretable way in order to digest it.
Yeah.
So the R&D team in the company actually tried to extract features, as I said before, and it worked plus or minus fine. But yeah, that's that.
Yeah, because I was wondering, you know, maybe as a data collection piece or data annotation, you could use the human to kind of like identify that noise, and then use that data to train the model, right? So put it on a time series. So every time they listen to it, inside of that 2-second window, and pinpoint that noise, and you collect enough of that, and then if you put it over time, you'll see some patterns maybe. If you perform that check for multiple, you know, motors over time, you'll have enough data for some sort of time series, maybe, you know, prediction of failure points.
So here you're talking about like classifying predictions, classifying anomalies. For example,
using
this
humans.
motor. Okay, yeah.
Using humans over time. So that
the problem is that we are trying to be problem agnostic. We just want to identify the good ones because there are many, many reasons why the motor won't be running okay. For example, if one of the screws isn't like tied well, it will like start vibrating and making this weird noise, you know, and like many, many other reasons. It has like 2,100 parts in the whole motor. Yes. So there are like various reasons why it might not work.
But yet a human is capable of knowing that particular noise that says it's failing, right?
Yeah.
Which is, you know, or do you have enough data that showcases that, you know, the human is capable of listening to any kind of noise?
Only 15 defected examples.
Yeah. Because that's the other approach I would take, right? Which is, okay, let's try a different type of model, but over time you need to collect that data from humans and then use that as a training. So that's all I have.
Thanks.
Excellent question, excellent discussion. Amar, thank you so much. Hopefully there's something in there that was able to help you. At the very least, you got Ben's email there, so hopefully Ben can get you guys pointed in the right direction. Look, let's go ahead and wrap this episode up. Thank you guys so much for being here. Appreciate y'all hanging out for this second anniversary party for the Artist Data Science Podcast. Damn, 2 years of podcasting. So yeah, check out the episode that was released today. Natalie Nixon. I was on Daliana's podcast just recently, the Data Scientist Show. So check that out. Bunch of other cool stuff coming in the next few weeks. Stay tuned. Just finished my first week at Pachyderm, so that was cool. Like drinking from the fire hose, it was awesome. Hopefully you guys will see me doing some more awesome stuff from there. Ben, thank you so much for the compliments of the gray beard. You know what? I'm starting to rock it, man. I've been hiding behind this dyed beard for far too long. It's time to just embrace it.
Looks good.
Embrace it. Thank you, man.
Thank you. Yeah, looks good, man. I do have a quick question for you, Harpreet.
Yeah.
What is that avocado for in your LinkedIn profile name?
Yeah. So I'm in DevRel now, right? So I'm still in data science, still in machine learning, but my role isn't a data scientist or machine learning engineer. I enable machine learning engineers and data scientists. So the avocado is the universal symbol for developer advocates, right? So you can see here, developer advocates. This is we're avocados because we're the good kind of fat in our organization. That's kind of the philosophy behind that. So you'll see a lot of people on Twitter who are developer advocates or in developer relations also have that avocado thing. So I'm embracing that since that is the direction I'm taking my career, because it is one hell of a career path to go. One day I will be just like Ben. So
appreciate you for satisfying my curiosity.
Yeah, absolutely, man. I'll probably be creating more content about what DevRel is, what DevRel is all about. So if that sounds like an interesting career path to you, I kind of described it at the beginning of this hour. But yeah, you'll be hearing me talk more and more about that. I feel like developer relations, if you are an open source platform, if you're a startup that develops tooling for data scientists or machine learning engineers, you've got to hire somebody in DevRel, or you've got to have a fully thought out DevRel function, because you spread the word and the message about the product, right? And traditional marketing doesn't really seem to work with these type of products and this type of persona. And that's where developer relations comes in. But yeah, I'll be putting more and more content out about that in the coming weeks. Guys, thank you so much for being here. Appreciate you guys joining me on the second birthday of the podcast. Got some awesome stuff coming up in the next few weeks. Obviously, I'll be at ODSC in Boston, April 19th. Hopefully you're there. 19th to the 21st, I'll be kicking it at the Pachyderm table. So come through. We got stickers and socks for you. And in terms of people taking over the podcast, Sadie St. Lawrence is supposed to take over the podcast in a couple of weeks. So definitely check that out. I think Mikiko, you might be taking over. Is that the end of the month or beginning of next month at some point? Yeah, it's coming up.
April 22nd.
The 22nd, that's right. So I'm excited for that. So guys, thank you so much. Appreciate you being here. Remember, you got one life on this planet. Why not try to do something big for everyone?